The Inca are really well known for their incredible stonework, which is called ashlar masonry. And the stones fit together perfectly without any mortar. It's almost like a jigsaw puzzle. They did not have the advanced technology that we have today, so it's really a marvel.
Everyone thinks Machu Picchu is a ruin. That's the lie. Perched 7,000 feet above sea level and carved into a living mountain, it isn't a city, a temple, or a royal retreat. It's a machine, and it never stopped running. Beneath those flawless stone terraces is a hidden system engineered to control water, absorb earthquakes, and keep an entire mountainside from collapsing. This isn't myth or mystery. It's documented science hiding in plain sight. And once you understand what Machu Picchu was really built to do, you'll never see it the same way again. Machu Picchu. Built on danger. For as long as any of us can remember, the story of Machu Picchu went something like this.
There's a story from 400 years ago about the end of the Inca Empire when the Spanish came in and took them over.
Sometime around the year 1450, the great Inca Emperor Pachacuti ordered the construction of a royal estate high in the Andes Mountains. His builders, the master stonemasons who could cut granite blocks so precisely they fit together without a single drop of mortar, carved a city out of a mountain ridge. They built temples, residences, plazas, and those iconic green terraces that cascaded down the slopes like a giant staircase. The terraces, we were told, were gardens, farmland, a clever way to grow potatoes and corn on steep terrain. The whole place was a retreat, a sacred sanctuary where the emperor could escape the noise of his empire and commune with the sun. That is the story. It is elegant. It is romantic. And for a very long time, nobody questioned it, because why would you? The image of Machu Picchu as a peaceful mountain paradise is one of the most enduring narratives in archaeology. It has been printed in every history textbook, narrated in every documentary, repeated by every tour guide who has ever walked those ancient paths. But stories, even beautiful ones, eventually have to answer to evidence. And when modern scientists finally pointed their instruments at Machu Picchu, they did not find a peaceful retreat. They found something that made absolutely no sense at all. Geologists, the scientists who study the bones of the Earth itself, made a discovery that should have rewritten every textbook overnight. They confirmed with hard data that Machu Picchu sits directly on top of a junction of multiple geological fault lines. Let me make sure that lands properly. A geological fault line is a massive crack in the bedrock of the Earth. It is a fracture zone where tectonic plates grind against each other, where pressure builds for decades and then releases in the form of earthquakes. One fault line is dangerous. An intersection of several fault lines is a place most engineers would mark on a map with a red circle and the words, "Do not build here." Machu Picchu was not built near a fault line. It was not built a safe distance from a fault line. It was built directly on top of the spot where multiple fault lines meet, on a mountain whose very skeleton is fractured and unstable. The ground beneath those beautiful terraces is not solid. It is broken. It has always been broken, and the Inca builders knew it. This is where the story stops being comfortable, because the Inca were not fools. We know this from everything else they built. Their road system stretched over 25,000 miles across some of the most brutal terrain on the planet. Their other cities were positioned with extraordinary precision, taking advantage of stable ground, water sources, and natural defenses. These were people who understood the land better than almost any civilization in history. So the question becomes unavoidable, and it is a question that should keep you up at night. Why would the most skilled builders in the ancient Americas deliberately choose to construct their most sacred creation on the most dangerous piece of ground they could find? This was not an accident. It was not ignorance. This was a choice. A deliberate, calculated, seemingly insane choice. And to understand why they made it, we have to stop looking at the surface and start looking at what is underneath. Over-engineered. Before we go deep, let us start with what we already knew, because even the surface-level engineering at Machu Picchu is staggering when you actually pay attention. The mountains where this city sits receive an enormous amount of rainfall every year. We are talking about roughly 77 inches of rain annually. To put that in perspective, that is nearly double the rainfall of London. Now imagine all of that water landing on a city built on a steep mountain slope, riddled with cracks. Without some kind of intervention, the entire site would have been washed down the mountainside within a few decades. Mud, stones, walls, all of it, gone. A brilliant American civil engineer named Kenneth Wright spent years studying how the Inca solved this problem, and what he found was nothing short of genius. Those 700 terraces that tourists photograph and call beautiful gardens are not simple platforms of dirt. Each terrace is a multi-layered drainage engine. And the design is so sophisticated that Wright himself admitted it outperforms many modern water management systems. Here is how it works. The top layer is rich, dark topsoil, perfect for growing crops. But beneath that topsoil is a layer of fine sand. Beneath the sand is a thicker layer of gravel and small stones. And at the very bottom sits a foundation of large, rough rocks. When rain falls, it soaks through the topsoil, gets filtered by the sand, and then flows rapidly through the gravel layer, draining away from the surface before it can pool, puddle, or build up pressure. It is a giant sponge and a drainage pipe rolled into one, repeated 700 times across the face of the mountain. This system accomplishes two critical things. First, it prevents erosion. The water moves downward through the terrace rather than across it. So the topsoil stays put. The terraces could sustain farming for centuries without losing their fertility.
Terraces are fundamental to Machu Picchu. While some terraces would have been used for small-scale farming, their primary purpose was to hold the mountain in place while draining a huge volume of rainwater away.
But the second purpose is far more important. By draining water so efficiently, the system prevents the ground from becoming saturated. When soil on a steep slope absorbs too much water, it becomes incredibly heavy. That weight creates pressure, and that pressure can trigger a landslide, which is exactly the kind of catastrophic failure that would erase a city from a mountainside. The drainage system at Machu Picchu eliminates that risk by pulling water out of the equation before it can become a weapon. Now here is where your instinct should start tingling. This system works too well. The level of engineering precision, the sheer labor of constructing 700 individually layered terraces, is massively disproportionate to the stated purpose. If all you needed was flat ground to grow corn, a much simpler system would have done the job. You do not build a Formula One engine to power a shopping cart. The drainage system is over-engineered by an order of magnitude, which means the builders were not just worried about rain. They were fighting something much bigger. And to see what that something is, we need to go deeper than Kenneth Wright or anyone else ever imagined. The invisible skeleton. For most of history, we could not look beneath Machu Picchu without destroying it. Digging is destructive. Excavation is slow. And the Peruvian government, understandably, was not eager to let anyone take a jackhammer to a UNESCO World Heritage Site. But technology eventually gave us a way to see without touching. And scientists deployed two extraordinary tools. The first is ground-penetrating radar, which works by sending pulses of energy into the earth and reading the echoes that bounce back. Different materials, soil, stone, air pockets, water channels, all reflect those pulses differently, creating a kind of X-ray image of what is buried below. The second tool is electrical resistivity tomography, which passes a harmless electrical current through the ground and measures how the current flows through different materials. Together, these two technologies gave us the first complete underground map of Machu Picchu. And what that map showed was, frankly, shocking. More than 60% of the total construction of Machu Picchu is underground. Let me say that again because it is the single most important number in this entire video. 60%. For every stone you see on the surface, in the walls, in the temples, in the terraces, there are at least 1.5 times more stones hidden below your feet. The city you recognize, the one on the postcards, is just the tip. The real structure is buried. It is a colossal subterranean framework of massive rough-cut stones, many of them far larger than the finely dressed blocks on the surface, all locked together and anchored directly into the fractured bedrock of the mountain. It is, in the most literal sense, a skeleton. An invisible skeleton holding the mountain together from the inside. Think about what this means for the farming narrative. The official story says that the terraces were built to grow food and the buildings were constructed as living spaces and temples. If that were true, and virtually all of the construction effort should have been focused on the surface, on the parts people would actually use. Instead, the Inca builders spent the majority of their time, the majority of their labor, and the majority of their resources building something that no one would ever see. They poured more effort into what is hidden than into what is visible. That does not make sense for a farm. It does not make sense for a retreat. It does not make sense for a temple. You do not use the steel budget of a skyscraper to build the basement of a bungalow, unless the basement is the point, unless the basement is the entire reason the project exists, and the bungalow on top is just a nice bonus. The invisible skeleton was not supporting a city. The city was a byproduct of the skeleton. And the skeleton was built to do one thing: hold a breaking mountain together. Dry joint mastery. Once you understand the skeleton, every other design choice at Machu Picchu suddenly snaps into focus. Take the walls. Those famous, gorgeous walls where enormous granite blocks fit together so tightly you cannot slide a razor blade between them. For centuries, people assumed this was purely aesthetic, a flex, a display of craftsmanship meant to impress visitors and honor the gods. It is impressive, no question. But beauty was not the point. The technique is called ashlar masonry, and the critical detail is this: there is no mortar. The stones are not glued together. They are not cemented. They are simply shaped with such precision that they interlock under their own weight. Modern structural engineers have a name for this approach, and they call it a dry joint system. And a dry joint system is one of the most effective earthquake-resistant construction methods ever devised. Here is why. When the ground shakes during an earthquake, a rigid wall, one held together with mortar or cement, resists the movement. It tries to stay still while the ground beneath it lurches sideways. That resistance creates stress, and stress creates cracks, and cracks create collapse. A rigid wall fights the earthquake and loses. A dry joint wall does the opposite. It moves. The individual stones shift against each other by fractions of a millimeter, absorbing the seismic energy like a boxer rolling with a punch. When the shaking stops, the stones settle back into position under gravity. The wall survives, not because it was strong enough to resist the earthquake, but because it was smart enough to move with it. The Inca builders were not showing off. They were engineering shock absorbers. Every wall at Machu Picchu is a seismic dampener, designed from the ground up to handle repeated, powerful earthquakes. And the choice of granite as the primary building material was not random either. Granite is one of the hardest and most durable natural stones on the planet. It does not erode easily, it does not crumble under pressure, and it can endure enormous compressive forces. They chose a material that would last centuries and assembled it using a technique that would let it survive the one thing that destroys everything else: the violent shaking of the earth itself. These were not architects building a pretty city. These were engineers building a survival machine. And the final piece of evidence, the one that removes all doubt, is where they placed their most sacred buildings. Pinned to the mountain, scientists created 2 maps. The first was a LiDAR scan of the entire city, which uses laser pulses fired from aircraft to generate an extraordinarily precise 3-dimensional model of every stone, wall, and structure on the surface. The second was a comprehensive geological survey of the mountain, showing the exact locations and orientations of every major fault line running through the bedrock. Then they did something simple that produced a result so startling it fundamentally altered the scientific conversation about Machu Picchu. They overlaid the two maps. They placed the architectural layout of the city directly on top of the geological map of the faults. The expectation was obvious. Any rational builder, knowing the ground was fractured, would construct their most important buildings on the most stable sections of bedrock, as far from the fault lines as possible. You build on strength. You avoid weakness. That is engineering common sense. It is common sense everywhere, in every era, in every culture. Except at Machu Picchu. Because when the maps aligned, the pattern was unmistakable and deeply unsettling. The most important structures in the city were not placed on the safest ground. They were placed with surgical precision directly on top of the most dangerous fault lines. The Temple of the Sun, with its famous curved wall, one of the most celebrated pieces of architecture in the ancient world, sits exactly over a major fault intersection. The Intihuatana stone, a carved granite pillar believed to have astronomical or ritual significance, is positioned right on top of another fault junction. The Temple of Three Windows, another structure of obvious ceremonial importance, aligns precisely with yet another fracture in the bedrock. Three of the most sacred, most carefully constructed buildings in the entire city, all placed on the three most geologically dangerous spots on the mountain. The probability of this being a coincidence is essentially zero. This was not careless placement. This was not ignorance. This was targeting. The builders identified the weakest, most fractured points in the mountain skeleton, and they deliberately anchored their heaviest, most perfectly engineered structures directly on top of them. They were pinning the mountain together. Each temple, each massive stone structure, was acting as a giant anchor driven into a crack, holding the broken pieces of bedrock in place. The most sacred buildings were not sacred because of religion alone. They were sacred because they were doing the most critical job in the entire complex. They were the pins holding a shattered mountain together. Before Pachacuti. Now, if all of this is making you uncomfortable, good, because the next part makes it worse. The official history says Machu Picchu was built under Emperor Pachacuti starting around 1450 AD and completed within a few decades. One ruler, one generation, one construction phase, clean, simple, fits neatly into the textbooks. But the engineering we have just described does not fit into one generation, not even close. The kind of geotechnical knowledge embedded in Machu Picchu, the understanding of fault mechanics, drainage engineering, seismic dampening, and subterranean anchoring is not the kind of thing a civilization invents overnight. This is generational knowledge. It is the product of centuries of observation, experimentation, failure, and refinement. You do not build something this perfect on your first attempt. You do not solve a problem this complex without a long history of solving smaller versions of the same problem first. The official timeline asks us to believe that one group of builders in one lifetime developed and perfected a system of mountain stabilization that modern engineers would be proud of. That is not plausible. And now we have physical evidence that confirms the doubt. Scientists extracted organic material, tiny fragments of charcoal and plant matter from beneath the deepest foundation stones, a material that was trapped there when those stones were first placed. Radiocarbon dating revealed that some of this material predates Pachacuti's reign by hundreds of years. The foundations are older than the empire that supposedly built them. But it gets even more compelling. The ground-penetrating radar surveys that revealed the invisible skeleton also found something else buried deep beneath the terraces we see today. Another set of terraces. Older terraces. Built in a slightly different style, but using the same fundamental engineering principles, the same layered drainage, the same deep anchoring into bedrock. Machu Picchu was not built in one phase. It was built in stages, over a much longer period, by people who already possessed this extraordinary engineering knowledge long before the Inca Empire reached its peak. The question of who those people were and where their knowledge originated remains unanswered. But the evidence is clear. The foundations of Machu Picchu are older than the story we have been told. Engineered to survive. A theory, no matter how elegant, no matter how perfectly it connects every piece of evidence, is still just a theory until you put it under pressure and see if it breaks. And a team of modern engineers decided to do exactly that. They took this hypothesis, this idea that Machu Picchu was never a city but a mountain stabilization machine, and they fed it into one of the most powerful tools humanity has ever created, a supercomputer. Not a laptop, not a desktop running simulations overnight. A supercomputer capable of performing millions of complex calculations per second, the kind of machine governments use to model nuclear detonations and predict the paths of hurricanes. They started by building a complete digital twin of the mountain inside the computer. Every detail that decades of surveys, scans, and excavations had revealed was coded into this model, the fault lines threading through the bedrock like cracks in shattered glass. The colossal subterranean skeleton of rough-cut stone anchored deep into the rock. The layered drainage system engineered into every one of those 700 terraces. The dry joint walls are designed to shift and absorb energy. Even the precise placement of the Temple of the Sun, the Intihuatana stone, and the Temple of Three Windows directly over the most dangerous fault intersections. Nothing was simplified. Nothing was left out. This was not an approximation, and it was the most accurate digital replica of Machu Picchu that has ever existed. Then they did the one thing the mountain has endured hundreds of times over the last 5 centuries. They triggered an earthquake, a major one. The kind of violent, ground-splitting seismic event that the Andes region is infamous for, the kind that topples modern concrete buildings and swallows highways whole. They unleashed it on the digital mountain and watched in real time how every component of the system responded. The results were not ambiguous. They were not partial. They were absolute. The system worked. Every single element performed exactly as the hypothesis predicted, not independently, but together as one unified machine. The massive underground skeleton locked the fractured bedrock in place, gripping the broken pieces of the mountain and preventing them from sliding apart. The drainage network kept the soil drained and light, eliminating the deadly water pressure that would have turned the slopes into a landslide. And the dry joint walls on the surface did exactly what they were designed to do. They moved. They shifted. They absorbed the seismic energy rippling up from below, acting as dampeners that bled the destructive force out of the system before it could cause structural failure. The temples sitting on the fault lines held firm, their enormous weight pressing down on the weakest points like surgical pins holding a fractured bone in alignment. The supercomputer did not merely confirm that Machu Picchu could survive an earthquake, it confirmed that surviving earthquakes was the entire reason Machu Picchu was built. In every stone, every layer, every wall, every terrace, every temple, one machine, one purpose, and after 500 years, still running flawlessly. So we return to the cliff's edge, looking at Machu Picchu one last time, but now the illusion is gone. What seemed like beauty is engineering. What looked ceremonial is structural. An entire mountain quietly held together by a system designed centuries before modern science had the language to describe it. 500 years of storms, earthquakes, and human footsteps, and the machine has never stopped. Which raises a far more unsettling question. If ancient builders could hide something this advanced in plain sight, how many other ruins are we still misunderstanding?